Bismillahirrahmanirrahim. Assalamu alaikum everyone. Hope you're fine and doing well. Welcome to the online lecture of MS291. In previous week, we covered the chapter 5 that was based on present worth analysis and future worth analysis. In that chapter, we learned how to use present worth or future worth to analyze several projects and to select the best possible alternative. Now in chapter 6, we are going to start annual worth analysis. So in this chapter, we learn how to use annual worth or annuity to analyze several projects and to select the best possible projects for your organizations or for yourself. So let's start by discussing the content of chapter 6. First of all, we'll learn some basics of annual worth analysis. Then I will demonstrate that the annual worth value is same for each life cycle. The next thing is to calculate and interpret the capital recovery and annual worth amounts. Then we'll select the best alternative using an annual worth analysis. Then we'll learn how to evaluate alternatives with very long lives using annual worth analysis. Here, very long life projects means uh, public sector projects such as railway tracks, roads, motorways, government schools, hospitals, universities that serve the needs of the public for a long time period, like 40 years, 50 years, or maybe more than this in some cases. So such kind of projects are known as public sector projects or long life projects. Then finally, we learn how to perform a life cycle cost analysis using the annual worth method. Let's start with basics of annual worth analysis. So if you remember, we have studied or discussed that this concept annual worth, annuity or equivalent annual worth many times before this chapter. So when we started the course in chapter 1, I explained you what we mean by present worth, annual worth and future worth. And in chapter 2 and chapter 3, we also discussed these concepts in detail. So here are a few different names for annual worth. Other names for annual worth are equivalent annual worth, equivalent annual cost, annual equivalent, and equivalent uniform annual cost. Even we can say annuity or annual amount or uniform series amount. These all things are same. Then annual worth and present worth and all other alternatives such as future worth will select the same alternative. It doesn't matter which method you use. The finally every method will help you to select the best project. Then if we talk about the definition of annual worth, so annual worth is an equal periodic series of dollar amounts that is equivalent to the total cash flows, inflows and outflows at MARR or interest rate. MARR means minimum attractive rate of return. In other words, if you say that you are going to receive or you have to pay 500,000 in coming 5 years. So now you want to know how much you have to save every year to to have 500,000 after 5 years to pay off your debt or liability. For example, if you know that bank is paying 10% rate of interest on deposits. So now you want to calculate by having 500,000 in amount and 10% market rate of interest in your mind to calculate how much you will deposit annually in a bank account that is paying 10% interest. So you will have 500,000 after 5 years. So the equivalent amount will be the annuity or annual worth that you have to deposit every month in the bank account. I will explain this concept with a brief example in coming slide. So then it will be covered for you. So it can be interchangeably used for annuity represented by A, as we have discussed earlier many times. So annual worth, present worth, and future worth has the following relationship. So these are the formula for calculating annual worth if you are given present worth and future worth. So annual worth is equal to present worth into A over P factor for a given rate of interest and number of years. So if you are given with future worth, rate of interest and time periods and you want to calculate annual worth, we'll use this formula. Annual worth is equal to future worth into A over F factor for a given rate of interest and number of years. So the n in the factor is the number of years for equal service comparisons. This is the LCM or the stated study period of the present worth or future worth analysis in case of different life alternatives. So if life of both alternatives is same, we can use the number of years straight away. If the life of both alternatives is different, as we discussed in previous chapter, we have to use least common multiple of the lives of both projects or the study period. Otherwise, it's okay. We can use number of years straight away if the life of both or all alternatives is same. So here is an example of annual worth. Let's say you are planning to start a business but lack financial resources, and your friend offers you to take rupees 2 million to start a business and return him 250,000 rupees per year for the coming 10 years. And the rate of interest in the market is 10% per year. Now you have to decide whether you will accept this offer or you will borrow the money from market at 10%. Which option suits you? So annual worth method will let you know if you borrow from market at 10% per 10% rate of interest per year, 2 million rupees. So how much you will need to pay annually? So we can calculate this amount at the rate of 10% per year for the market. If we borrow from the market, then we'll cover the resultant annual amount with the 250,000 that we have to pay in case we borrow from friend. So if the amount is less than 250,000, then we'll borrow from the market. If the amount is greater than 250,000 that we have to pay any financial institute, if we borrow from the market, then we'll accept the offer of friend. First of all, let's draw a cash flow diagram. So here is a cash flow diagram. We are given with the present worth that we can borrow at time 0, that is 2 million rupees, and we have to pay it in 10 equal installment for coming 10 years. So here the annuity is unknown. We need to calculate annual amount that we have to pay every year. Rate of interest and time periods are also known. So here is the formula in case you are given with present worth, number of years and rate of interest to calculate annuity or annual worth. So annual worth is equal to present worth into A over P factor for a given rate of interest and number of years. So present worth is 2 million, A over P factor for 10% and number of time periods are 10. So the factor value is 0.16275 and multiply it with 2 million, the amount will be 325,500. Now in that case, if we decide to borrow 2 million at 10% rate of interest for 10 years from market, we have to pay 325,500 rupees every year. On the other hand, if we accept the offer of our friend who is offering us 2 million and demanding us to return 250,000 per year for coming 10 years, so 250 is less than 325. So definitely we should accept the offer of our friend. So in that case, the answer to this question is yes. Now, if you want to confirm the factor value, here we have factor table, rate of interest 10%, A over P factor for 10% and 10 years row. The factor value is 0.16275 and multiply with 2 million, the result is 325,500 rupees. I hope this is clear for everyone. If you have any question, you can write to me and I will try to address them in a better way. Now the next thing is the annual worth value determined over one life cycle is the annual worth value for all future life cycles. So I will prove this assumption in next slide. It means if you calculate, it means if we have alternatives with different lives, so we need to calculate annual worth for one cycle and the annual worth for coming life cycles will be the same. Therefore, it is not necessary to use the LCM of lives to satisfy the equal service requirement in case of annual worth analysis. But it is important to remember that annual worth method is also based on the assumption of equal service requirement or equal life assumption. So here is the example different life alternatives, and will prove the assumption that we discussed in the previous slide. National Home Builders Incorporation plans to purchase new equipment. Two manufacturers offered the estimates below. So we have two vendors, vendor A and B, and we are given with initial cost, annual cost, salvage value, and life in terms of years. So if we talk about vendor A, the initial cost is $15,000, annual cost is $3,500, and salvage value is $1,000. Life for vendor A is 6 years. And if we talk about vendor B, initial cost is $18,000, annual cost is $3,100, salvage value is $2,000, and life is 9 years. Now if we see, the life of both alternatives is different. For alternative A is 6 and alternative B is 9 years. And we need to determine which vendor should be selected based on the present worth comparison if the MARR is 15% per year. Then we also need to demonstrate the equivalence of present worth over 3 life cycles and annual worth over one life cycle at rate of interest 15%. So we'll show that if we calculate present worth over 3 life cycles, and then we'll use this present worth to calculate annual worth. So the annual worth for each life cycle will be same at given rate of interest. Let's start by calculating the present worth. So National Home Builders Incorporation evaluated equipment from vendor A, whose life is 6 years, and vendor B, whose life is 9 years. The present worth analysis will be based on the least common multiple of life. So the least common multiple in this case will be 18 years, 6 and 9. So the LCM is 18 years. So we need to consider only the option A now. So consider the cash flow for all 3 life cycles, for example, 18 years. First cost is $15,000, annual cost is $3,500, salvage value is $1,000, and life is, so the LCM of lives is 18 years, sorry. So here is the solution. First cost 15,000, annual cost 3,500, salvage value $1,000. So the present worth of project A will be here minus 15,000 initial investment in first life cycle and minus 15,000 with P over F factor for 15% and 6 years. So this is the initial investment for second life cycle at the end of 6 years. Then this is the salvage value at the end of first life cycle, which is $1,000, and we need to convert all values in present amount at time 0. So we'll use equivalent number of years to convert them at time 0. So here 15,000 is being invested at the end of 6th year, and we need this amount to be at time 0. That's why we are using P over F factor for 15% and 6 years to have this amount at time 0. Then 1,000 salvage value coming at the end of 6th year. Again, we are converting it at time 0 by using P over F factor for 15% and 6 years. Then this 15,000 investment for third life cycle at the end of 12th year, which is again converted at time 0 by using P over F factor for 15% and 12 years. Then this is the salvage value for this year for third life cycle. Sorry, for the second life cycle. P over F factor 15% and 12 years, and then this is the salvage value at the end of third life cycle. 1,000 P over F factor 15% and 18 years. Then finally, these are the annual operating expenditures for every year starting from year 1 and ending at year 18. That's why you're using P over A factor for this annual amount to have it time 0 with 15% rate of interest and 18 years. Now the next thing is using factor values, multiplying with their respective amounts and having the answer. So the present worth of project A will be $45,036. So this is a negative amount because this is a cash outflow, and cash outflows are represented by negative sign. So we have calculated the present worth of option A, that is $45,000, $45,036. Now the next thing is to calculate annual worth of first cycle for project A. So initial investment is minus 15,000. We need to convert it into annual amount by using A over P factor for given rate of interest and number of years. Then this is a salvage value at the end of the first life cycle. So A over F factor for given rate of interest and number of years. Here we for 15,000 we used A over P factor because this is a present amount, and for 1,000 we used A over F factor because the salvage value will receive at the end of first life cycle, that is a future value. So we'll use A over F factor. Then with annual operating expenditures we have written them as it is because this is already an annual amount, and we are calculating annual worth for first life cycle. That's why we do not need to make any calculation to convert this 3,500 into annual amount. So here are relevant factor: 15,000 A over B factor for 15% and 6 years, then 1,000 salvage value A over F factor for 15% and 6 years, and 3,500 these are annual operating expenditures for first life cycle. And the answer is minus 7,349. So annual worth of one cycle is 7,349. Now we'll use the present worth that is calculated based on 3 life cycles, and we'll convert that amount into annual amount, and we'll see whether this amount is equal to annual worth calculated for one life cycle or not. So the present worth of alternative A for 18 years is given as $45,036. That is calculated in previous slide. So now we can calculate annual worth by using this amount, A over P factor for 15% rate of interest that we used for first life cycle, and the 18 years, that is the life on the basis of least common multiple of lives of both projects. So the answer is same, $7,349. You can use the factor value, calculate the amount, and the both amounts will be the same. So hence prove that annual worth calculated based on one life cycle will remain same for the rest of the life cycles as well. Hence one life cycle's annual worth value and the annual worth value based on 18 years, 3 life cycles are equal. I hope this concept is clear for everyone, and that's enough for this lecture. I will prepare another video for the rest of the topics that we have to cover in this chapter. So please feel free to ask if you have any question, and apart from your written request to address your queries, we'll also have an interactive session so you can have another opportunity to discuss your queries. Stay safe. Hope to see you in next lecture. Bye bye. Allah Hafiz.